So we're going to look at ground effect now. So here we have an aircraft hovering outside ground effect. Our induced flow is acting downwards, and because we're high up, you can see it's just going straight down. So building up our vector diagram, you can see you've got our plane of rotation and axis of rotation. We bring in our aerofoil and our chord line. You can see we've got our rotational airflow. We've got our induced flow acting, and you can see we've got quite a lot of induced flow there, which is giving us our relative airflow. From there you can see we've actually got quite a big angle of attack. 90 degrees to our angle of attack is our lift, followed by our drag and our total reaction. See here then we've got our rotor drag, and we've got quite a lot of torque opposing that rotor drag. We've got our total rotor thrust and our weight acting opposing it as well. So now we get our aircraft hovering inside ground effect. So you can see here as our induced flow acting downwards, and because we're close to the ground, it's building an area of high positive pressure underneath our rotor blades. Because we're doing that, we can see what's going to effectively happen now is we're going to induce, eventually all this pressure here means we're going to reduce our induced flow. So our IF reduces, which changes our relative airflow, increases our pitch angle, our angle of attack. So if our angle of attack increases, acting 90 degrees, that is our lift and our drag and our total reaction. And we can see our lift and drag has increased. But as we draw it down, our actual rotor drag has actually reduced. Therefore, our torque reduces as well. Our total rotor thrust is increased, as we can see, and therefore the aircraft is going to want to climb. So to oppose that, our pilot is going to lower the lever. So our torque is going to decrease further, and it's going to balance it all out. Which is why we can hover inside ground effect using less power. So 4 factors that are going to affect this. Our slope. So if we're landing on a slope or hovering above a slope, our induced flow is just going to flow downwards like that. If we've got a wind blowing, obviously it can blow it away. Our height, so up to 2/3 of your rotor diameter above the surface, you can be inside ground effect. So for a aircraft with smaller rotor blades like a HE135, you might have an inside ground effect up to maybe only 20-25 foot. But for a Chinook, you can have ground effect up to potentially about 40 foot with a 60-foot diameter of its rotor blades. And then finally, the surface. So again, if you have an uneven surface like this is what's going to effectively happen to our induced flow, and it's not going to allow it to build up that positive pressure.